In this video, let us look into some of the important trigonometric identities and also prove that sine squared theta plus cos squared theta equals 1. So sine squared theta plus cos squared theta equals 1 is one of the most fundamental and important trigonometric identities. So let's prove this. Now when we set to prove this, there are three cases now. Mainly the values of theta, right? So first case is when theta equals 0. So what happens when theta equals 0? Sine square 0 degrees plus cos square 0 degrees. Sine square of 0, sine 0 is 0, so sine square 0 is going to be 0. Cos square of 0 is 1, so 1 square is 1 again. So we've got 0 plus 1 equal to 1 and our RHS. So we proved this identity when theta equals 0. What about when theta equals 90 degrees? We've got sine square 90 degrees plus cos square 90 degrees. Sine square 90 degrees is 1, so it's 1 square plus cos square 90 is 0. 0 square is 0. So we've got 1 plus 0 again equal to 1. Again, RHS proved. It proves fine for theta equals 0 and theta equals 90 degrees. So what when theta is in between 0 degrees and 90 degrees? When theta is an acute angle. So to prove that sine square theta plus cos square theta equals 1 when theta is an acute angle, we need a small construction here. Say, so now let x a y be equal to theta be the given acute angle. Let P be any point on the side AY other than A. Alright, so P is another point other than A on the side AY, and draw perpendicular PM from P on the initial side AX. So now in triangle AMP, we have sine theta equals PM by AP and cos theta equals AM by AP. The reason is sine is nothing but opposite by hypotenuse. So the opposite to theta is PM and the hypotenuse is AP. For cos, it is adjacent by hypotenuse. The adjacent is AM and the hypotenuse is AP. So we've got sine theta and cos theta. So now let's use this sine square theta plus cos square theta. We've got sine square theta plus cos square theta equal to, in the place of sine square theta, let's substitute PM by AP, that is sine theta, right? So it's going to be PM by AP the whole square plus cos theta is AM by AP. So therefore cos square theta is going to be AM by AP the whole square. So now what we've got is PM squared by AP square plus AM squared by AP square. Notice that the denominators are the same. So we can write PM square plus AM square divided by AP square. So now what is PM square plus AM square? According to the Pythagoras theorem, we have the hypotenuse square, that is the AP square, equal to the sum of the square of the other two sides. That is AP square equals AM square plus PM square. AM square plus PM square equals AP square, right? So here it is. AM square plus PM square becomes AP square. So AP square by AP square equals 1. So we start off from sine square theta plus cos square theta, replace that by these sides, solve them and reach 1. So hence sine square theta plus cos square theta equals 1. And hence we proved this particular identity for three cases, that is when theta equals 0, when theta equals 90 degrees, and when theta is any value between 0 and 90 degrees, that is when theta is an acute angle. So therefore sine square theta plus cos square theta equals 1 for any value of theta here, that is between 0 degrees and 90 degrees. Before I conclude this video, let me quickly, this is a simple thing. From this identity, we can also say that sine square theta equals 1 minus cos square theta. Or we can write cos square theta equals 1 minus sine square theta. So these are the two other identities that we can deduce from this equation. Yeah, so in the forthcoming videos, let us also prove more important trigonometric identities like this.